Today's a big day. Today we talk about first derivatives and second derivatives and third derivatives and fourth derivatives. You can take a derivative of a derivative. And it's fun. It's very applicable to real life as well. We're going to show you that in a second. What you need to do is you want to look at this, and one of these is the original function. One of them is f. Then another one is f prime, another one's f double prime, another one's f triple prime. I want you to visit, take 2 minutes, you try to figure out if you can find out which one is f, and then which one's a derivative, derivative. See what you can do, okay? Try to just think through problem solving that we're going to talk about, okay? Go, have fun. Okay, so there's a few things that you have to think of when you look at these derivatives. Okay, number one, I'm just gonna pick one out right now. I'm gonna look at the green one. Okay, as I look at this green one right here, what can you tell me about the slope of that green function? It's always negative. Therefore, its derivative must always sit below the x-axis. Correct? And so I know that the derivative of the green function must be which one? The yellow. Exactly. That's the only option. Everybody agree? Now, that doesn't tell me which one's the original, but I know the derivative of the green is the yellow. I know that for sure. I'm going to look at something else here. I have this blue function. Notice that this blue function is the only one that has a slope equal to 0, isn't it? So that means that the derivative of the blue must be which one? The red, because the red one is the only one that crosses the x-axis. Look, the slope is equal to 0 there, so the red one crosses 0 there. So that means the derivative of the blue must be the red. The derivative of the blue must be the red. How do we know that the blue is the original? Very, very easily. Look right here. The blue function crosses 0 at that spot. Do any of the other functions have a slope equal to 0 at 1? No. The yellow's positive, the red's positive, the green's negative, the purple's negative. So you know that the blue is the original. That's F. So let's move from there. What's F prime? The red one. The red one is F prime. Notice that the derivative is negative, 0, positive. So the red one is negative, 0, and then positive. So that's F prime. What can you tell me about the slope of F prime? It's always positive, so therefore its derivative must be sitting above the x-axis. So therefore it's either which or which? The green or the purple. Which one is it? Why is it the green? Yep. That is F double prime. So what's F triple prime? Yep, the puke colored one. Good job. And so we do write F triple prime, but after that, we do not write F triple prime or F quadruple prime. What we write is the purple one here is going to be F, and then you just put parentheses with a 4. That means the fourth derivative. The fourth derivative. Okay. All right. Good work. Find the first and second derivatives of the following functions. No big deal. F prime of x. What's the first derivative? 4x cubed minus 8x plus 2. What's F double prime of x? 12x squared minus 8. No big deal, huh? F prime of x. What rule do you use to find the first derivative? Chain rule. I don't even need to make the boxes. We can do it quickly. What's the derivative of the inside? 2. Derivative of the outside. 5u to the 4th. So I will have 10u to the 4th. I will now find the second derivative. Derivative of the inside. Times the 10 will be 20. Drop the 4, I'll get 80. 2x minus 3 to the third. If you want to make the boxes, make the boxes. But there comes a point where I say, let's just take the derivative of the inside times the derivative of the outside with the inside left alone. And we roll. Flip it. Square root of 2x minus 3. I'm going to set up the boxes. I notice that sometimes here we make mistakes. What is the outside? U to the 1/2. What's the inside? Derivative of u to the 1/2. And derivative of 2x minus 3, 2. So notice when we multiply those together, the 1/2 and the 2 will cancel. Isn't that fortunate? 1 over the root of 2x minus 3. Sometimes people look at that and they use the quotient rule. Just use the chain rule again, right? U to what? Negative 1/2. Two x minus 3, 2. Negative 1 over 2 u to the 3/2. Is that the derivative of u to the negative 1/2? Multiply them, and 2's cancel again, and I get negative 1 over 2x minus 3 to the 3/2 power. That's f double prime of x. No big deal, huh? You can find first derivatives, you can find second derivatives. Second derivative is extremely useful, and you're going to see a couple examples later on of how that works out. But right now, let's try one slightly more challenging. F of theta is equal to theta times cosecant of theta. F prime of theta. You tell me something intelligent about this. How do I take the derivative? Product. I'll treat this as F. I'll treat this as G. What is F prime? 1 times cosecant of theta. Plus theta times, what's the derivative of cosecant? Negative cosecant of theta, cotangent of theta. So I'll rewrite this as cosecant of theta minus theta, cosecant of theta, cotangent of theta. First derivative wasn't bad, but that second derivative looks like it could be nasty, huh? See, a few of you saw this earlier in your assignment from 3.5, that you had a section where you had to use the product rule twice. So if you just maybe looked at the answer key and said, oh, I think that that's what the guy did. You should know how to do that. Let's see how we handle that. F double prime of theta. Starts off with the derivative of cosecant. What's the derivative of cosecant? Negative cosecant of theta, cotangent of theta. I then have a minus sign, correct? I'm going to subtract that derivative. Goodness. So everybody see that? We're going to have to use the product rule twice here. I call that F, and I'll call this G. So I'm looking at
f prime g plus g prime f. Do you know what f prime is? It's right here, isn't it? Does everybody see that? It's important you notice that. I'm afraid not everybody's picking it up. But I want to find the derivative of theta cosecant of theta, right? That's what we just found the derivative of, correct? So we already have that. It's right here. Do you see that? So we're going to use that. I have cosecant of theta minus theta cosecant of theta cotangent of theta. Yeah. Times what? Cotangent. We're doing f prime g. So g is cotangent of theta. Oh, don't want that parenthesis yet. Plus or minus plus. What's g prime? What's the derivative of cotangent? Negative cosecant squared of theta times theta cosecant of theta. So all we're going to do is we're just going to write it so we distribute our negatives through. Try to clean that up just a little bit. All right, do anything drastic. Negative cosecant of theta times cotangent of theta. I'm going to put this minus parentheses. In here, it looks like when I distribute the cotangent, I get cosecant of theta times cotangent of theta. I have a minus. When I distribute the cotangent here, I get a theta cosecant of theta cotangent squared of theta. And it looks like I have a minus theta times cosecant cubed of theta. And my last step here, I'm just going to distribute the subtraction sign. Does anybody see any like terms that will combine? I have a -1 minus another one is going to be -2. So -2 cosecant of theta cotangent of theta. So we distribute the negative, we're going to get a plus theta cosecant of theta cotangent squared of theta plus theta cosecant cubed of theta. And that's f double prime. So we've shown you a couple examples where the first few work out really, really, really nice, right? And then you can take something like this, which looks really, really, really easy, and all of a sudden gets super, super, super challenging, doesn't it? So I wouldn't say that you would need to do something like that on the test, but I would say all the others are pretty much straight up what you need to be able to do. But this is to try to heighten your understanding that multiple derivatives can be very difficult. Suppose they asked us to find f triple prime. Right, exactly. Last problem of the day. You're going to have some good time to work through your assignment. And we're going to do some type of a review activity tomorrow. You will not have a lesson. Good time to get caught up on some work. I would like to, in this problem, find y prime and y double prime. In order to understand how to do this, you must have been here for class yesterday. Had you not been here yesterday, you won't know what's going on unless you watched the video. Okay. Who can tell us how we start by finding y prime? (18x) plus 2y prime is equal to 0. A for the day for whoever can tell me without looking. What do we call that type of differentiation? Start with an implicit differentiation. That means that for Sydney Nelson, give her that a round of applause. Wearing the Jackrabbit shirt today. She thinks she's going to college. It's so cute. Good job. Of course you're going to college. Of course you're going to college. All right. What? It was a joke. I was trying to play a joke. So the reason why we call it implicit differentiation is because there is not a variable explicitly solved for. So y is not explicitly solved for. You did a great job. What I do is I subtract the 18x. I get 2y, y prime is equal to negative 18x. And I divide by 2y. So y prime is what? Negative 9x over y. So now we're going to move to y double prime. And this is going to be a little bit involved. This you definitely need to know how to do for the test. Trust me. So when we get these type of situations, this graph, I don't know if you all realize it or not, but do you know what graph this makes? If you were to sketch this graph? Close. An ellipse. Yeah. So it's an ellipse because you have, if you had a 9 in front of the y squared as well, then it would be a circle. They would be stretched the same amount. So when you have these type of shapes, their second derivatives end up pretty cool. So hopefully you'll notice this. What rule do you think I used to find y double prime? The quotient rule. Derivative of the top. Negative 9 times the bottom. Y minus the derivative of y is y prime, 1y prime. So plus 9x y prime over y squared. So in order to simplify this, you want y double prime in terms of x and y. You don't want a y prime in there. So I got to get rid of this y prime beast that's going on. How do you think I get rid of that? How do you think I get rid of that? How do you think I get rid of the y prime? Yeah, you substitute negative 9x over y in for y prime. Okay. So, yeah, thank you. Little complex fractions could be going on. So we've got negative 9y plus 9x times negative 9x over y all over y squared. Samantha saw what was happening. She said what? She said, oh, now we got a complex fraction. How do we handle complex fractions? Common denominators. She's on a roll. Multiply top and bottom by what? Y. And when you multiply top and bottom by y, we get y double prime is negative 9y squared minus 81x squared over y squared over 1. Now, as we have a complex fraction, what do? Multiply it by the reciprocal, so we have a 1 over y squared. So we have a negative 9y squared minus 81x squared over y cubed. going to require you to see something. Lexi started to say something. Nope. When we whisper, I can't hear as well. Take out a what? Okay, let's take out a -9. Not because we necessarily see something, but we just maybe after we take out a -9, we will see something. So we've got -9 times, and then you'd end up with a positive 9x squared, and you'd end up with a positive y squared, correct? Over y cubed. Yeah, look at it. Yeah, Connor and Riker see it. Good job. What is 9x squared plus y squared? What is 9x squared plus y squared? It's 4. Yeah. So we're going to replace the negative or the 9x squared y squared with 4, and you end up with -36 over y cubed. There you go. That is the second derivative. Quotient rule. So I want to find the derivative of this guy. You got it now? Good job. So I want to be clear that if you get the graph of the equation for a circle or an ellipse or a hyperbola, that it will, generally break down to something like that. It's pretty cool. Good job. You ready for your assignment?